Good morning. My name is Ken Weissner with Cisco Systems. I'm currently a technical marketing engineer in the HA areas. I cover basically all aspects of doing HA technologies within Cisco routers. I think the reason why I wanted to come and speak to you about this was a colleague of mine attended a previous NANOG, and there were some questions about Graceful Restart that were brought up during one of the peering BOFs. And I've got a slide or two inside here, and I wanted to come and perhaps give some more information on the topics and hopefully clear up some terminology and things like that. So the title, I spent a lot of time worrying about putting too many acronyms up there, but there's a lot of different moving parts here, so I wanted to make sure we covered everything. So going right into a couple of definitions of all the different things that we have. The term HA is a very high-level terminology. In and of itself, it doesn't necessarily mean a whole lot, right? So you want to dig down into some of the different, like I said, moving parts of what happens in order to accomplish a route processor switchovers. Stateful switchover is one component of being able to switch processors over. It essentially, it's an operating mode between, on a router where you have two processors or two processes. And basically the nuts and bolts of stateful switchover is the ability to transfer information from one processor to the other, so that if a failure occurs, that other processor has whatever information it needs in order to pick up in a fairly timely manner. Non-stop forwarding, we somewhat have a little bit of a dual meaning for this terminology, and really the term non-stop forwarding, the word forwarding is the key portion of this, is really the ability of the router to continue to forward packets while the control plane recovers. So in a distributed system, typically that's, forwarding is handled by the line cards while the control plane recovers from the event, whether through either a graceful restart mechanism or a non-stop routing mechanism. So moving on to Graceful Restart, basically Graceful Restart is IETF mechanisms that are it's designed for both peers of a routing protocol session to communicate the ability of a device to necessarily lose connectivity for a few moments, and the Graceful Restart mechanism basically allows the peer to allow the switching over device a little bit of time to come back without doing all the normal things it would do if the peer went down. Typically, if a routing protocol peer goes down, the very first thing that happens is we flush the routes that we learned from those peers. Using Graceful Restart, it basically gives a grace period to the device for certain periods, and different protocols have different timers. And if the peer comes back within that certain amount of time, we'll go ahead and revalidate the routes and continue to forward. All during that time frame, we forward packets to the device that had just switched over as if nothing had occurred. And really, in order to perform Graceful Restart, both sides have to have the knowledge of the ability to do Graceful Restart. So it's you need to make sure you've got those IETF specified mechanisms coded into the device that you're using. Non-stop routing is basically a mechanism to be able to maintain the session completely without any type of interaction with your routing protocol peer, right? It's all done within the box, right? So any information that's needed to maintain that peer and all the associated information with that peer is essentially stored within the box, so that when a switchover occurs, there's no necessity to interact with the peer at all through Graceful Restart mechanisms. And it can be desirable in the cases where the peer doesn't have the capability to do Graceful Restart. You could run nonstop routing on that interface or peering relationship, and you still, the end device, the CE device, the remote end, won't see the peer go down if a switchover occurs. So basically, those four technologies or so, the SSO, the nonstop forwarding, the Graceful Restart, and the NSR, they basically all work together to allow a unplanned switchover to occur and have the router lose a very small amount of interruption to it. There's There's always some, especially with our current platforms, there's some issues with very slight reconnect time on the backplane. So there is a slight interruption in packets, but for the most part, packets continue to forward through the router. One last term is in-service software upgrade. Basically builds on all of these technologies to allow you to do planned switchover from one processor to another processor, which actually upgrades the software on the router while you're doing it. So there's a little bit more intelligence that's added to the SSO capabilities, but essentially it's just doing a switchover between two versions of code. So this just goes into a little bit about why do people why are they interested in SSO NSF? Initially, I mean, you really are looking in your network for your single points of failure, boxes that are terminating a lot of different single connected C devices. You might have dual processors in that, and it's really a box that you want to have 5 nines of availability on. So this allows you to put some protection inside that box and really upgrade the uptime of that particular router. The last point on there about leveraging distributed nature, again, this goes back to the point of the nonstop forwarding component of it, where the distributed line cards use nonstop forwarding to forward the packets while the router reconverges the control plane. We do actually are able to perform these on non-distributed platforms. Functions a little bit different internally, but the external experience is pretty much the same. Very little packet loss. These are just some quick slides that go over, kind of what happens, on a network before we do Graceful restart and without once we've implemented it. And the key here is that with these technologies, with running NSF SSO and Graceful restart, there's really no interruption to the flow of traffic when a switchover occurs. There's no adjacency failures. You may see the adjacency go down in some cases, but the Graceful restart mechanisms allow for that, and so there's no actual adjacency failure. So, and again, this kind of goes through what happens once we put in the Graceful restart mechanisms, and the key here is in the number 1 slide you'll see that the CEs have a GR aware, and that points out that in order to use the Graceful restart mechanisms, that any protocol peers have to have an understanding of the Graceful restart capability in order to participate with the boxes that's switching over. This slide quickly goes through the IETF status of all the different Graceful restart mechanisms for all the various protocols that are supported. There is basically we support supported is LDP, BGP, ISIS, and OSPF. There's a draft there for a mechanism that Cisco pioneered previous to the adoption of a lot of these other mechanisms for Graceful restart as well. The eventual IETF approved RFC is listed there for OSPF as well. So I kind of just said a couple of these points. We also do Graceful restart for EIGRP, and then the 2 different versions of OSPF that I just mentioned. Again, one was a Cisco implementation before the drafts were fully ratified, and it's actually pretty widely deployed inside networks today. The last point about a router participating in Graceful restart is said to be either aware or capable. And awareness is mostly, or it is a subset of capability. Basically, if you are a device that is capable of switching over, you need to have devices that are aware of your capability. So your peer devices are going to be your aware devices. And sometimes you'll hear the term aware and the term helper mode also used. The 2 terms are fairly synonymous. And this slide basically kind of goes into the mechanisms that are used for establishing the fact that the peers can do graceful restart. And again, each protocol perhaps has a little bit of a different mechanism, but from a high level, the peers are going to announce to each other that they either are capable or aware, and based upon that, they'll decide whether or not they're going to do graceful restart or not. And again, the last little point about sometimes you'll hear these terms of aware and capable and helper, and just keep in mind that awareness and helper are pretty much the same thing. A little bit about some implementation details about configuration. Well, not necessarily specifics about configuration, but in order to enable the capability portion of graceful restart, it's not turned on by default on any of the routers. You'll need to go and enable that. The awareness capability for interior routing protocols like OSPF and ISIS and EIGRP, if your device is running Cisco code that supports it, then it's turned on by default, so you won't need to visit interior routing protocol peers to turn something on. It'll just come up and start running once you turn it on the devices you're interested in protecting. TCP-based protocols, LDP and BGP, need to be configured on both sides, and sessions reset before the graceful restart capability will be in function. And that's mostly because the information saying, I'm capable of doing this is contained in the BGP and TCP open messages for those protocols. So interior protocols, if you turn it on, it'll start running automatically. But from an implementation standpoint, if you have BGP or LDP, it's going to require a session reset before it'll start working properly. So this is actually the slide that I had seen from NANOG 40. And basically they're saying that the concern is, and this is a very common concern that we hear, is how do I determine between, if I'm a peer of a device that's capable of switching over, so if I'm an aware peer, how do I determine if that peer is just switched over or if that peer has actually gone away, right? And I think that, it's a very good question. I don't know that I have a complete straight answer for it, but it comes down to somewhat of individual analysis of of the particular scenario that you're in, right? So again, determining between this is typically one of the biggest questions that I get as far as how can I ensure that I know what exactly the event is. So just one point and this again goes back to some of the terminology. I think that we Cisco have used the term NSF with kind of a dual meaning. In some sense, NSF can be used to describe the function of graceful restart, but in reality, they're really kind of two different things. You never really configure NSF on the router. It's really a function of Ceph checkpointing that transfers all of the Ceph information either to the line cards or to the standby so that it can do that forwarding capability once the switchover has occurred. The next bullet there just says that it was just basically an eventual evolution of the way some of these protocols have worked. We kind of got into this dual meaning of the term NSF. So I guess it's important just to remember that when and the specific example I'll give you is OSPF. In order to enable OSPF capability, you go into the command line and type the term NSF. And essentially what you're doing there is you're enabling graceful restart. You're not really enabling NSF. NSF is kind of a core function of the router that gets turned on automatically. So there are some timers, and this goes back to actually looking at the failure scenario versus the switchover scenario. There are a couple of timers within BGP Graceful Restart that can help with this. There's a timer that allows the longest amount of time before the peer is capable of coming back up. Right, I'll go back to this slide right here. And the statement here says that it can be many minutes before the peer can really recognize that there's been a problem. And there's the timers here for the restarting the BGP session. The default is 120 seconds. But given an understanding of network conditions, that timer can probably be reduced to something a little bit lower to say, if the peer goes down and doesn't come back within 30 seconds, assume he's not coming back, right? The default, like I said, is 120 seconds, at least in Cisco iOS, and that is you can slide it either way depending on what your particular scenario is. There's other conditions that will abort Graceful Restart as well. I mean, if you have a point-to-point link over a POS connection and that link goes down, the router is going to realize outside of the Graceful Restart process that that peer is no longer capable or is no longer up and running. This is just a quick slide that kind of shows the IETF mechanisms for doing BGP Graceful Restart. You notice at the top there's the open message carries the Graceful Restart capability, and the red arrow there on the left-hand side actually shows the point of the switchover, right? The router that just switched over will send an open with the restart bit set on. And as soon as the BGP aware peer gets that message, it's gonna, that's the point where it's gonna stop the restart timer and it's gonna start what's called a stale timer, right? So he starts a stale timer and he also puts all of his routes that he learned from that particular peer into a stale mode, right? Now he'll continue to use those routes, but the routing table will show that they're stale, and if nothing else happens, they will eventually stale out of the routing table, right? So the peer establishes the session back up, does the normal bringing session up just like it normally would, and then it basically dumps all the routes back down to the peer, and there's an additional message that's added in called the end of rib. And that's basically the way of the peer telling the GR aware device to say, I've given you everything that you need to know. You can now do what you need to do, which is, build a new table based upon what he's learned, and then he compares that against everything that he has that's stale. Because it's possible that, routes will change during some of these processes, and it's important to be able to, act upon those changes as well. We go ahead and clear out the stale entries, getting rid of any entries that we didn't hear of before the end of rib, stop the stale timer, and the entire process is finished. So this slide actually goes through a little bit of the differences between the two different versions of OSPF Graceful Restart that Cisco supports. Essentially, the kind of high-level messaging here is that both mechanisms pretty much work the same way. They both do the same thing. They just use different messaging and different mechanisms to do some of those. For example, in order to tell the peer, the RFC-based version uses a new type of LSA called a Grace LSA. In order to notify the peer on the Cisco version, we use a signaling bit in the LLS fields inside the hello packets. And again, there's a couple of different things back and forth as far as what would happen if a peer is in the middle of the Graceful Restart process and it gets an update from a route. The RFC based actually says, if it gets an update from behind somewhere in the direction of the router that switched over, the RFC based says, abort out of Graceful Restart, and giving you the opportunity to configure that. And the Cisco version basically says, continue until it's complete. And I think there's a little bit of a philosophical discussion back and forth about which mechanism is better. And like I said, we now support both versions of these, so you have a choice of which you need to deploy. So quickly on nonstop routing, Cisco currently supports nonstop routing for ISIS and BGP. Again, it's an inbox solution that doesn't require any additional communications to any of your routing protocol peers. For interior protocols, the NSR acts on the entire routing protocol, the entire routing process. For BGP, NSR can be enabled on a per peer basis. And we have a hybrid solution that helps with the scalability of BGP NSR deployments. And basically, move on to the next slide. This is the idea here is mainly that somewhat of the compelling reason to use NSR is that if you don't have the capability of turning on Graceful Restart on your peer device, right? So the idea of the hybrid solution is more of you're more likely to have the capability of running Graceful Restart on your route reflectors that are internal to your network rather than your CE devices. So since you have the opportunity to run it there, and since most of the routes for a particular router probably come from the route reflector, it's probably better to run Graceful Restart towards your route reflector and use NSR in the direction of the CE devices, where you can protect individual peers with fewer number of routes. There was also some questions at the same BOF about per peer configuration for both Graceful Restart and for nonstop routing. So currently in Cisco IOS, the BGP configuration is global. If you turn on Graceful Restart, it'll act on all peers. And there are some improvements coming on the horizon for that. I think that's the third bullet down, or the fourth bullet. BGP for NSR is currently a per peer config on the router, so you can individually choose which device you want to run nonstop routing on. And then the third bullet on there basically says that even if we tell a peer to run nonstop routing, if we hear Graceful Restart messaging from them, we'll choose to run Graceful Restart over nonstop routing. So a couple of kind of deployment considerations. Kind of from a high level, you need to have a mechanism to protect your interfaces / layer 2 mechanisms, right? And when I say interfaces, I mean if you have a PPP session, there's going to be some state information associated with that. So you're going to need to use the ability to send information to the standby, which is SSO, in order to be able to maintain that. The second is maintaining the forwarding plane, which is, again, the nonstop forwarding component. And essentially that's just a mechanism of transporting the fib down to the standby and line cards so that they can be used while there's a transition in the control plane. And then protecting the control plane, which is accomplished either via Graceful Restart or nonstop routing. One thing that I've kind of run into in the past is people want to try and say, well, I want to enable SSO and then let it burn in my network for a little while, and then I want to come and enable Graceful Restart after that. And really, all these features kind of work together to provide the redundancy and protection on a switchover. So it's really kind of considered as one feature together, and really should be enabled all at the same time, or else you're going to get perhaps potentially non-deterministic results. It requires a lot more investigation of what might happen if you use the individual features, whereas the behavior tends to be much more deterministic if you use it all kind of as designed. The last bullet there, or the second to last, about enabling SSO, also enables NSF. Again, this kind of goes back to some of the dual terminology of Graceful Restart and nonstop forwarding. Even though there are some config commands that use the term nonstop forwarding, in the true function of how it works on the router, you don't actually enable it. When you use the mode SSO command, it actually enables NSF for you. There is no configuration. And then, each routing protocol that you have on the box needs to be examined to make sure that, it has, its peer has the awareness set up appropriately if you're using nonstop, if you're using Graceful Restart, and that it's learned those awareness capabilities from its peers. So one other thing that one other question that tends to come up a lot, and this kind of goes along the lines with the conversation of how do I know the difference between a real event and a switchover event, is a lot of routing protocol timer manipulations that customers like to do. real common in scenarios where your uplink from a P is a gig link that goes to a switch, right? You've got no real way of telling via link down if there's a problem. So a lot of people like to reduce their OSPF, hello and dead timers so that they can get faster convergence, right? The switchover mechanism, as soon as the new processor takes over, it takes a little bit of time for the new processor to start, sending either its OSPF hello or the different protocol hellos. So if you crank the timers down really low, you may run into situations where the switchover will actually cause Graceful Restart not to work because the background, hello and dead timers are still working on the session. And if you don't hear if you got your dead timer at 3 and you don't hear anything for 4 seconds, the session's going to go down and you won't even have the opportunity to enter into Graceful Restart mode. So really the point there is that you really kind of need to do some good testing in your lab to figure out what kind of tolerance you have before you consider doing something like cranking your timers all the way down to 1 and 5. For something like BGP, using timers like 10 and 30 is typically not a problem because we can get that first packet out well within that, before we pop the 30-second timer. But like I said, when you get to 1 and 5 timers, it can be a little bit more problematic, and a little bit of investigation of your particular node is probably in order for that kind of thing. And now I'd like to open it up for any questions. No questions. Thank you very much.
Thank you very much, Ken.